Have you ever died behind a wall? Have you ever died before you even saw the enemy? Is this a skill issue? Am I ever going to be happy? To stop asking ourselves these type of questions, I have created this. And now we can finally study why you suck at FPS games. Say hello to the Netcode Simulator. The Netcode Simulator is a real-time network artifact sandbox written in C++ that uses Raylib. You can host a game, join it from a local network, manipulate latency, packet loss, and tick rates, and finally find out, is it really the latency? Or am I just bad at this game I have sacrificed my best years to? The Netcode Simulator also allows you to record sessions, export event logs, and then do statistical analysis on the data. This is the first part of my new series about the development of the Netcode Simulator. In this series of videos, we're gonna talk about its features, the development and ideas behind it, and I'm gonna do a code review on the project itself, which will be very interesting for many reasons. In this video, we are focusing on its features and not how it's implemented. You can download it, build it, play around with it, mod the code for your own experiments, and maybe even contribute something. So we are going to talk about the game modes, multiplayer and single player, the gameplay recording system, the replay studio, the event log export, and then I'm gonna show you the level editor. Now, in order to understand how the simulator works on a basic level, let me briefly explain what is happening under the hood. So usually in online multiplayer games, you have a client and a server, right? And if you watched my Netcode series, you have seen this like a million times. On the most fundamental level, the server holds the authoritative game state and the client sends commands to the server. The server updates the authoritative game state and sends the new game state back to the client. Now, what the Netcode Simulator does is this. Between these two components, we put a network adapter component. Now, this network adapter receives the input, applies the network parameters we have configured like latency, packet loss, and so on, and then sends it to the server in two lanes. One lane contains the original, non-manipulated packets. This is our control group. And the other lane contains the manipulated packets. So these packets can be artificially delayed, dropped, reordered, or whatever else we want to test. This gives us the ability to manipulate network artifacts in a controlled way. And since we have both the manipulated and the non-manipulated packets, we can render both versions, compare them, and also apply specific game rules as we go. That means the Netcode Simulator allows us to see what the gameplay looks like from each player's perspective. It gives us a netcode sandbox where we can control all the parameters of an online multiplayer game without the overhead of some bloated, full AAA game running in the background. And it also gives us the option to record sessions and export full event logs with timestamps. For example, things like when did the attacker enter the defender's field of view? When did the shot happen? When did the server process it? And so on. And since the source code is open, you can change basically everything. The player movement speed, the character shape, the camera position, the field of view. So the project is not only trying to simulate latency, it is trying to give you the whole loop around it. And that's basically the whole idea. You can get the source code on my GitHub, and here are some build instructions, and as you can see, it runs on my machine, of course. Okay, so first let's start with the game modes. You have multiplayer and you have lab study, which is basically the single player mode. The difference is that in lab study, nobody can join your game, but you can add bots, of course. If you want to go back to the menu, you can press back or just use the shortcut Q. In multiplayer, you can either host a game or join a game. If you host a game, you have first to select the level. These are the thumbnails of the levels, and currently all the default levels look more or less the same. So we select a level and then we can adjust the session settings or just start the game. And don't worry, all of these settings can also be changed during runtime. Then we select the team, attackers, defenders, or we can join as a spectator, and that loads you right into the level. You can now walk around, shoot, do a triple jump, and behave like a completely normal FPS player. Now, the shots are on a 2D axis, so you can aim up or down visually, but your shot is always fired at the same fixed height. This is obviously something that we can change in the next version, don't worry. If you don't know what the key bindings are, you can just press K and open this key binding dialog window, whatever. And some of these are only available in specific modes. For example, the orange marked ones are specific to the spectator mode. The purple ones are used in recording mode, and so on. Now, in case you want to release your mouse because the game captures it during a session, you can press enter. That will release the mouse. Okay, now since walking around is boring, you can also add bots. So you can press tab to see the score, and then you have these host options. Only the host can see these, okay? You can add bots by pressing this button. It always adds 2 bots in a balanced way, and then you can change their teams or kick them. This play button makes the bots start playing the game. So when you add them, they will just stand in place and do absolutely nothing like most corporate people. And this gun button toggles between peace mode and gun mode. In peace mode, they will not shoot. In gun mode, they will shoot. So you can make them walk around with or without shooting at the opposite team. Okay, now let's add some bots. Okay, now we have some bots, and then we can jump on this block and let them play. So as you can see, they just walk around and they don't shoot. But if I turn the gun mode on, they immediately start shooting, like it's a Balkan wedding or something. I can now press B and enter the spectator mode. I can fly above them and watch them shoot at each other. Now, we still haven't changed any network parameters yet. If we press U, it opens the runtime settings. Here, for each player, we can adjust the network settings. Things like latency, packet loss, upstream and downstream delay, and so on. Besides the player-specific stuff, we can of course also change the session settings. Do we have interpolation? Is client-side prediction enabled? Which shot evaluation strategy are we following? Are we using the server authoritative game state, or are we honoring the shooter's point of view? Then we also have the game tick rate, the server snapshot rate, and so on. We can now turn the interpolation on and off, which is immediately visible when turned off. We can turn the client-side prediction off, which basically makes you wait for the server acknowledgement for every command. You can adjust the engine tick rate, and this is not to be confused with the snapshot tick rate. Snapshot tick rate is the frequency in which the server sends snapshots to all the clients. Now, also important to mention, you can't turn the snapshot rate higher than the tick rate, because it does make sense. You would just be oversampling it, okay? In that case, you're sending 2 snapshots for the same tick, which means you're not advancing the game before sending the new snapshot. You're just sending the same snapshot twice. I've talked about all of these things at length in my Netcode series, okay? So in case these terms are confusing in any way, go watch these videos. And the best way is to start with the first one, which is the Quake 3 Netcode video. Okay, now since we are hosting the game, I can start another instance of the Netcode Simulator and join the game from the local network. So we open another instance from another terminal, then we go to multiplayer, join the game, and it shows us the available servers. Then we can join the game and start playing. And that's the basic gameplay. You can play around with the network settings and observe what is happening in real time. Now, that is the, let's call it, main layer of this project. But since this is supposed to be a tool for analyzing why you suck at FPS games, we need more than that. We need to be able to record sessions, look at them from different perspectives, export the data, and then do statistical analysis on that data. So this is the part where it goes from just a network simulator sandbox to something more like a scientific research tool. Now watch this. During gameplay, let's say we want to analyze and research the peaker's advantage. We can press O to open the recording mode overlay, and now when I press 5, it starts recording the session. And now we can start playing. So I walk around the corner, I see someone, and I shoot. And now I can stop the recording, and then I can take a look at it, go back and forth, play it again, and press 9 to save it. Now you're probably wondering, yeah, but that's only one perspective, right? Well, actually, no. It records the whole session. So while watching the recording, I can switch to spectator mode and observe it from any angle. Or I can switch characters and look at the same encounter from the enemy's perspective. Okay? And now comes the cool part. While watching a recording in spectator mode, I can set spatial checkpoints. So let's say I like this camera angle. I can press 1 and set a checkpoint. And then for the second part of the encounter, maybe I want to look at it from a different angle. So I just go over here, press 1 again and set another checkpoint. And now I can switch the camera between those two checkpoints with the keys 2 and 3. So 2 goes back and 3 goes one checkpoint forward. And all of this also works while we are watching the replay. So I can play the recording and then switch camera angles during playback to make it more, let's say, cinematic. Also, if the transition time between two checkpoints is too short or too long, I can press comma or dot to increase or decrease it. And you can see the transition duration here. If you don't need a checkpoint anymore, you can press 4 and delete it. Now, let's say you like this recording. As I said before, we can press 9 and store it. And later on, you can go into the replay studio, find your session, replay it, create checkpoints, make a screen recording of it, and that's it. An important implementation detail is that just like in modern multiplayer games, the recording is not capturing the rendered screen, okay? It captures the commands. So you're basically reconstructing the actual gameplay that happened. And this gives you the full possibility to later evaluate the session on a command level, because the commands are going through the same engine again, okay? We have talked about this. Now, that is the visual side of it, but we also need data. So in order to not bloat the log while you're just trying stuff out, I made the logging work like this. You have to actively turn it on. So when you're in the game and press U, it opens this configuration panel. You can turn event logging on. And when you're done, you can just turn it off. I'm sure there's a more elegant way to do this, and I'm also sure we are going to have some pull requests immediately coming in. Currently, the log is not logging every command. It is not creating a full record of the whole gameplay, and that is not even the point of an event log. In the event log, we only want the most important events with timestamps. Now, the timestamps can be tick-based or they can be in seconds. What I wanted to capture in these logs is the exact moment when one player enters another player's field of view, and then all the important events of that encounter like shots and kills. And this is exactly what we want for research projects. We want a controlled environment and we want an actual timestamped event log. We don't want to measure it only like, yeah, the attacker wins most of the time, which is valuable information, don't get me wrong, but it is much more valuable to know how big this advantage actually is. And then we can ask more interesting questions like, how does the movement speed of the players affect this? What happens if we change the physical appearance of the characters? What if we make them carry bigger weapons or make the shoulders bigger? And exactly that kind of stuff you can study with the Netcode Simulator. I have read many studies and research projects like this, but none of them gave the source code for free, like none of them open sourced their setup. And yeah, I know there are ways to analyze stuff like this in some games, but then again, you have to install the game, you have to make sure your machine is running at high FPS, you have to deal with a bunch of other stuff. You can't just change the engine code as you go, and everything is basically game dependent. And the reason I built all of this is because if you want to understand something, you need data. You need to know what happened. When did it happen? And why did it happen? Was it something maybe nobody even thought about? And this is not only true for game development. It is also true for basically anything you deploy to the internet. If you have ever deployed a website, an API, or some cursed little server sitting in your basement, you know the worst way to find out something is broken is through customer feedback. And that is exactly why monitoring exists. You want to know when something goes down, gets slow, or starts behaving weirdly before everyone else has to tell you. And that brings us to our today's sponsor of the video, Uptime Robot. Uptime Robot monitors your websites, APIs, servers, endpoints, SSL certificates, and all that beautiful infrastructure that likes to fail only when you're not looking. And when something breaks, Uptime Robot can notify you through email, mobile, Slack, and a bunch of other integrations. You can also create public or private status pages, so instead of answering the same "is it down" message 47 times, people can just check the status page. They also have a free plan with 50 monitors, which is honestly enough to give you a glimpse of what the tool is actually capable of doing. And if you want to try one of the paid plans, you can use my promo code TARIQ10X to get 10% off. So check out Uptime Robot, click on the link in the description, and make sure you find out your website is dead before the whole internet does. Okay, now back to the video and let's take a look at the replay studio. So you can go in here and replay all the sessions you recorded. Again, the advantage of this is, especially for scientific purposes, is that you can get a full record of the whole session, which is very important if you want to make something reproducible. You can rename sessions, delete them, load them, and then inside the session, you can again enter spectator mode and start creating camera checkpoints. Then you can take a screen recording with all the right camera angles, and I'm completely aware that we could make a direct video export, and that feature will probably come, but I didn't want to bloat the whole thing before getting any kind of feedback from you. Okay, so we have covered the gameplay, the recording mode, the replay studio. Now let's take a look at the level editor. In the level editor, you can create levels, and I tried to make it as simple as possible. You can place objects, you can resize them, you can move them, delete them, change their colors. Then you can also plant bots, and you can mark areas. Now you're probably wondering, what is an area and why would anyone need it? An area is basically just a differently colored part of the floor where you can toggle its visibility on and off. Why is it useful? Well, if you remember some of my videos, I use this trick to mark areas when explaining things. So I mark sections green or red to indicate something. It has no impact on the gameplay whatsoever. It's just a visual artifact, okay? Now, back to the level design. I'm thinking about expanding the level design so that we can have stairs, slopes, floors on top of floors, and so on. But since in this first version you can't really shoot up and down, it's everything on the same level, I didn't see a reason to implement that feature yet. Okay, then you can save your level, and now in starting a game you can play on your own level, which is cool. So that's it for the level editor. What is left is the settings menu. You can change key bindings, screen size, and so on. And you can also resize it with your mouse freely. Okay, now let's talk a bit about the development of the Netcode Simulator and what my plans are for this project and the video series. As you know, I draw a lot of diagrams. And when I was preparing the Netcode series, I quickly realized diagrams are cool, but I want something I can actually click around. Something interactive that gives you instant feedback. So somewhere around October last year, I started coding the latency game from scratch in C++ using the SFML library. And you probably remember the first Netcode videos where it was this 2D top-down shooter with a Dust 2 looking map. But at some point I wanted to turn it into something more, I don't know, looking 3D, I guess. And I also wanted something that gives me the same vibes as the Man in Python library. If you don't know what Manim is, it's this Python library where you write equations and it draws these really nice mathematical visuals for you. Now, in the Netcode series, we looked at scientific studies on Peeker's advantage. We talked about subtick, different netcode strategies, and if you watch those videos, you probably remember these little figurines. And that was the first, let's say, version of the latency simulator, which now has become the Netcode Simulator. And after I finished the videos, I basically abandoned the project. Because from my perspective, that was the scope of the project. It has served its purpose and it was done. But over the months, I kept getting requests from people asking me to talk more about the latency simulator or to share the code with them. Some were doing some sort of scientific research on netcode, and some people were working on their own netcode projects and asked me if I could help them get the netcode right. And in many cases, I actually did send people the source code. But the code was not exactly a real tool. From my perspective, it was not that useful, to be fair. So I decided to clean it up, refactor it, and turn it into something other people can actually use. Because as you know, I'm something of a scientist myself. And last year, when I recorded the full Netcode series, when I was done, I realized that a lot of the interesting stuff is not just who shot first or how much ping did someone have. It's the exact timing of everything. When did the player shoot? When did the enemy enter your field of view? When did you enter the enemy's field of view? What was the actual reaction time on average? How much of what happened was caused by latency, interpolation, bad tick rate, or just human interaction time? So my goal was not to understand the Counter-Strike better, or Arc Raiders, whoever is playing Arc Raiders, or any specific game. The goal was to understand what happens under the hood on a basic fundamental level. So people can actually see what is going on, test different scenarios, and maybe finally understand why online games sometimes feel random. And at the beginning of the year, I started working with a colleague on a more serious project. We were testing AI coding capabilities, running local models, and doing a bunch of other stuff in that direction. And at some point we decided, you know what, let's create our own AI coding harness. Not because we wanted to build yet another wrapper project, but because we wanted to experiment and see what the current state of the technology is actually capable of doing when you fine-tune the whole workflow to the best of your abilities. And the harness is not just a big pile of markdown files saying, you are now a senior software architect, or you are now a senior UI designer, or whatever. It is still a prototype, but it seems to be able to produce software. And now, one part of the whole equation is, okay, it can produce software, but how good is the software it produces? I mean, you can look at all these benchmarks, like this model beats that model in this benchmark, or this model is 3% better at solving some coding puzzle. Bubble sort this, bubble sort that, bubble sort these nuts. But what is it actually able to do when you use it in a controlled environment, focused on creating a useful piece of software? Not beating a benchmark and not solving some isolated coding puzzle. And then I got the idea. Everyone has been asking me about the latency simulator, so why don't I use the harness to refactor it and see how it goes? And I have to be completely honest with you, I would never have had the time to do this refactor line by line myself. Like, never. Between my corporate job, my consulting stuff, my other projects, and, responding to people asking for help in any project, which I genuinely love doing without being sarcastic in any way, I could probably work 1 day a month on the latency simulator. And at that pace, it would have taken me at least a year, probably. Obviously, these are rough estimations. This is not empirical, peer-reviewed evidence on my, efficiency. But you get my point. The fact is, It can be useful. Anyone saying it's completely useless is just coping at this point. And now keep in mind, we're not talking about code quality yet. But from a user perspective, the result is spot on most of the time if I use the harness correctly. So the next part of this experiment is actually looking through the code and doing one of my code reviews on the application created by this harness. So in the next videos, I'm gonna break down the ideas and architecture behind the Netcode Simulator. And then we are going to do a code review on it. And after that, I'll give you my personal opinion on the result. Okay, now I want to take the moment and say a big thank you to my Patreons and YouTube members. If you want to support the channel, you can become a Patreon or YouTube member, or you can use my Ko-fi link. Your support helps me immensely to create better and better content. If you like the content, leave me a comment, subscribe, like, share the video on other platforms, and that's it for today. See you in the next one. Tariq 10x.